Chapter 11, Section 6, Evaluation of Classification Performance, Part 2. As we saw in the previous video, accuracy is the most popular metric to evaluate performance of a classification model. However, as we know, accuracy does not provide us with sufficient information when the class distribution is imbalanced. We can use other metrics to compensate the weakness of accuracy. As such metrics, let me introduce recall and precision. As expressed by this formula, recall is the proportion of predicted positives to actual positives. It quantifies what proportion of actual positives was correctly predicted as positives. And as expressed by this formula, precision is the proportion of actual positives to predicted positives. It quantifies what proportion of predicted positives is actually positive. Recall is important if overlooking positives is a serious problem. For example, when we want to detect a disease that requires immediate medical procedure. Precision is important if false positives generate much cost. For example, in a case of customer churn prediction, we need to take some measures to retain potential churners by some sales promotion campaigns. We should know that there is a trade-off between precision and recall. Let's see this issue using simplified examples. Suppose we have 16 observations, and 10 of them are actual positives, and the remaining 6 are actual negatives. Let's apply a classification model to this data and compute precision and recall. To compute precision and recall, we need to know how many of the observations are true positives, false positives, and false negatives. So, let's count them. Let's look at the first example. The orange shaded area represents predicted positives, and the green area is predicted negatives. As we can see, this model classifies only 4 observations as positives, and none of actual negatives are predicted as positives, whereas 6 actual positives are predicted as negatives. Therefore, there are 4 true positives, 0 false positives, and 6 false negatives. Thus, precision is 1.0, and recall is 0.4. Let's go on to the second classification model. This model classifies 8 observations as positives. That is, this model covers more positives than the first model, but by doing so, it falsely classified an actual negative as positive. In this case, there are 7 true positives, 1 false positives, and 3 false negatives. Thus, precision is 0.875, and recall is 0.7. Let's look at the next example. This model covers more positives than the second model, but therefore, it contains more false positives. The precision is 0.75, and the recall is 0.9. As we can see, as the precision increases, the recall decreases. That is, precision and recall are in trade-off. It is because the more observations a model classified as positives, the model is less likely to overlook actual positives, and therefore the recall will be high. However, by doing so, the model is more likely to falsely classify actual negatives as positive, and therefore the precision will be lower. But fortunately, we have another measure called F1 score, also called F measure, a metric that addresses the trade-off between precision and recall. F1 score quantifies the degree to which both precision and recall are high. The formula is a bit complicated, but the point here is that F1 score will be high, both precision and recall are high. And it will be lower if one of them is high but another is low. So, we can use F1 score as a balanced metric to evaluate a classification performance. If we compute F1 score for examples in the previous slide, we can obtain these values. As we can see, in terms of F1 score, the third example is the best model. We have seen 4 types of metric for evaluating classification. There's no one best metric for all situations. We need to choose the best metric depending on the problem we address. Let's summarize the points in this chapter. There are various algorithms for classification, and there is no one that performs the best in all situations. So, we should try various algorithms and employ the best one that achieves the highest performance in our current problem. Ensemble learning can achieve higher prediction performance than a simple model by combining multiple models. However, we should know that models using ensemble learning method do not necessarily achieve higher performance than a single model. As for model evaluation, there are various metrics to evaluate a classification model's performance. We should use multiple metrics for versatile evaluation or choose the most appropriate metric depending on the problem we want to solve. Thank you for watching. Please thumbs up and subscribe to my channel.